Jerry, you got any plans this weekend?
I got what?
Plans this weekend?
Yeah, I'm working tomorrow, like I always work on the weekends, and then Sunday, I'm not sure what we're doing.
Richard Grace is logged on.
Guess I'll be the only festive one there is.
Who do we got right now? We got Richard Grace. We have Mike Wiesner, Brandon Runyon.
Sounds new.
Says exciting topic. Never done this before. Josh Kovac. Billy Beckett is on. Norm Hughes.
Do different people tune into this show compared to the Open Go 2?
Sometimes.
Show?
Sometimes we, a lot of the same.
A lot of the same, but there are some that are new that come in.
Yeah. But that's cool. We like it.
Heck yeah, we do.
Yeah, we do.
Yeah, we do.
Sounds like Yabba Dabba Doo.
Yabba do.
So you guys got giant plans this weekend?
Giant? No.
I want an image, by golly, but the weather needs to cooperate.
Yes, it do.
And I need to test your mount too.
Did you talk to Scott about what we're doing with his?
Yeah, he laughed at me, said that was ridiculous, that Jerry would have fixed it immediately. Just the usual.
Yeah.
I told him that we're going to send West one TDM. See either if he can replicate the same results or if it's user error here that's causing some of the problems.
Our Milky Way's central black hole has a leak. This supermassive black hole, over 4 million times more massive than our sun, looks like it still has the remnants of a blowtorch-like jet dating back several thousand years. NASA's Hubble Space Telescope hasn't photographed the phantom jet yet, but it has helped find circumstantial evidence that the jet is still pushing feebly into a huge hydrogen cloud. This is further evidence that the black hole is not a sleeping monster, but periodically hiccups as stars and gas clouds fall into it. The hiccup results in superheated material blasting away from the black hole as narrow beams, or jets, shooting in the same direction as the black hole's spin axis, along with a flood of ionizing radiation. As the jet blows through the gas, it hits material, which creates a series of expanding bubbles that extend out to at least 500 light years. The streams continue to percolate out of the Milky Way's dense gas disk into the galactic halo. Scientists concluded that the black hole clearly surged in brightness as much as 1,000,000-fold in the last million years. That would be enough for a jet to punch into the halo of material that surrounds the galaxy. This Hubble image of galaxy NGC 1068 shows a similar scenario occurring. Previous
Hey, Scott.
Hubble and other
Yes.
telescopes
Everybody's saying there's no sound coming from the video.
have now
I can hear it really low.
that was
Oh.
energetic enough to create an immense pair of bubbles towering above our galaxy that glow in gamma rays. Hubble was used to see how fast the bubbles
It's a silent film.
were made of. Hubble later found that the burst was so powerful that it lit up a gaseous structure as far away as 200,000 light years from the
That's
galactic
better.
hole. Called the Magellanic Stream, seen here in pink, this gas is still glowing from that event even today. The residual jet feature is close enough to the black hole that it would become much more prominent only a few decades after the Milky Way's black hole powers up again. Whenever that does actually end up happening, it's sure to be quite a spectacular show.
Well, hello, everybody. It's Scott Roberts with Explore Scientific and the Explore Alliance. And today's program is going to be, for many of you, a very critical program because it's about drift alignment. This is a method of precision polar alignment that you can use. It's extremely useful if you can't see pole stars, for example, or if you want the best alignment of all for astrophotography. So it kind of beats out many other so-called shortcuts towards getting a precision polar alignment. And it is something that once you learn how to do this, I think you'll really enjoy it because it takes care of so many problems that you can experience, including things like internal flexure in a telescope. So that can affect polar alignment. I'm going to turn this over to Tyler Bowman and Jerry Hubbell. And thanks for bringing this on, guys.
Sure. Thanks, Scott.
How's it going, everybody? It's another Friday. We've made it. Just a couple more weeks till Christmas.
That's
Yay.
right. So did you actually have lights strung up in your backyard when you were imaging Comet Leonard?
Yes, I did.
Cool.
Yeah. Excuse
Cool.
me. So, guys, we have a very special guest. Everybody knows who this guy is. Unfortunately, it is Jerry Hubbell. No.
Unfortunately.
Jerry has kind of been a mentor for me. And since I started working here, he's helped me try to understand the PMC8 or any kind of software issues that I'm having. And I've always scratched my head with drift alignment, because drift alignment, there is not enough information, in my opinion, or at least easy enough information to interpret and understand, because it gets real technical really quick. Some videos kind of help, but that's why I called the man in that's done this forever, so he can basically tell you how to understand it and what's the procedure to get this done. So I'm going to turn it over to Jerry, and he's going to tell you how to get this done the correct way.
You're not going to ask me questions?
Oh yeah, we'll ask you questions. Don't you
Okay,
worry.
good.
That will happen.
I always like questions from the audience too, especially. It's always good.
I already
You know
have
what?
a couple.
You know what the secret about when you're up on the podium talking, giving a presentation or anything, when people are really interested when they ask questions, and they're really not interested when they don't ask questions.
Well, I have a couple already. I already have a couple questions already waiting.
So that's putting pressure on the audience a little bit, I guess. But yeah, so I've got some sources for some information also to help you. But you're correct, Tyler. It is kind of somewhat technical in the not necessarily in the performance of the drift alignment to do your polar alignment, but in terms of what's going on, okay, with your scope and the sky. If you can get your head wrapped around that concept on what actually is going on, then it'll make easier sense to you, and you can understand the procedure a lot better. That's always the key to understanding and to doing any kind of process or procedure, is to really understand the basis for why the procedure is the way it is. You know, why you have to do these things to get a, in this instance, a good or near perfect polar alignment. So I'm going to bring up, let's see if hopefully this picture won't be too confusing for people. I'll try to explain it. I've got a couple of web pages that have a good source and have some drawings that I want to try to show here. Give me a second and I'll see which page I need to bring up here. Not it.
So if there are any questions that the audience want to ask, I know Pekka has one. I know he's got a particular question, but we're going to get into a little bit more information first before I ask Pekka's question, because he asked me earlier this week, because he's one of those individuals that can't see any guides or any NCP or the southern in the southern hemisphere. I believe he's in the southern. I think he is. But he wants to learn drift alignment. And that's what kind of sparked this episode, was because of Petka. So I'm hoping that once he gets a better understanding how to do this, then he can pass that information along to somebody else that's having trouble, or maybe he can come out with a better guide. Who knows? We'll just have to wait and see.
Right.
But
so,
go ahead.
Let me go ahead and share this drawing. Now, this drawing is going to seem somewhat complicated when you first see it, but I'll explain it and point out the main features of the drawing that you really need to understand. Now, you see that?
Oh, look, more technical.
There are really only 2 or 3 main things to understand about this drawing that it shows. And let me I'm going to post this link for this. This is a great source for polar alignment information. It is a drift alignment home page, and I'm gonna give you that. And then on the left, there's these items in the menu. So let me paste this to the chat, and then you can paste it out there on the.
Yeah, that works.
So let me get a chat. Will be okay. So here's the link. This page, and this drawing I want to show basically describes what's going on, okay, in the sky, between your sky and the telescope, and why this will work, okay. So look at the green line here and the green arc across the sky. Okay, so this zenith is straight up. So imagine yourself in the center of this plane right here. All right, and you look straight up as zenith. You look over, and there's the pole star. Okay. Now, when you first plop your telescope down and get it close to the North Pole in terms of the right ascension axis, remember you're trying to steer the right ascension axis so that it is basically in parallel to the Earth's polar axis, because that's what the Earth rotates around that axis, and that's in the position in the sky where there's no movement is the North Celestial Pole or the South Celestial Pole. This applies equally to the South Celestial Pole. Okay. So you can do drift alignment on the north or the south, it doesn't matter. So you got the Earth's axis, which points to the pole, to a location in the sky, which is the North Celestial Pole. And then you plop your mount down, and your mount is not aligned with that initially, right? It's pointing off. That's what this red line is. That's the telescope's axis, the right ascension axis on the telescope. So what that causes, okay, when you have the axis and the telescope axis is not lined up, you have a different arc across the sky that the telescope moves, right? Think about this as zero declination, okay? Think about this as the equatorial axis. The celestial equator basically is right here in green. And when you plop your telescope down, it says, oh, the celestial equator is along this line, but it's not, right? Because it's not lined up. So what declination drift is that depending on where you're pointing in the sky, that delta, see this delta right here in the position in the sky between the telescope's track in right ascension and the actual celestial equator is off. It's off a certain amount. Now, depending on whether you're east or west, it's going to be more or less, right? So the maximum amount it's going to be off is when you're pointing at the meridian, okay, or dead south. That's the maximum difference between those two. When you're east or west, it's minimized, okay? So when you talk about declination drift, as the telescope mount tracks the sky from east to west, okay, that value departs more and more from the true value, okay, and that's the drift. As you go along in time, that value, that position gets further and further away from the celestial equator, and that's the drift and declination. That's what the cause of it is. Okay, does that make sense?
Makes sense to me. Waiting to see if the audience is going to say if they have questions, concerns, or comments, to at least understanding the graph. So I don't see anything yet, so let's go ahead and continue.
So that's the root cause. I would call that the root cause of declination drift, is this polar alignment offset, which is what we all knew, right? So it makes sense. All right, so I don't know if I can show any more of these really that have any good drawings. Okay. There's some graphs there. All right, so let's go back to another, let me go to another, let's see if I can find another. Okay. There's another website that talks about it, and I want to share this link. So let me get that to you. You can share this. Another good source for information. Now this is going to get into the actual procedure on how to do the drift alignment. All right, and it does some explanation. So so this is kind of what, let me see here. It's kind of hard to understand these drawings unless I really, first two rules for Southern Hemisphere. So I don't really want to read this procedure word for word to people in the audience. That's boring as hell. But I wanted to be able to describe what's going on here based on these drawings.
Well, in my opinion, let's try to sum it up the best. Like for Petka, he if I understand his question, but this is his words, but I'm not seeing the meridian on the south, and I wonder if I can take a star before the meridian and hope I will get the line before meridian flip.
Okay, so let me speak to that directly. So part of the procedure is you have to put your telescope, point it in the sky to two separate locations. Okay, when you point it to the meridian, well, there's the two locations are the meridian, or near the meridian is near zero declination, and the other position is near the horizon, maybe 20 degrees or 30 degrees of 20 degrees above the horizon on the celestial equator. So
how close do you have to be to the meridian for it to?
You could be 5 or 10 degrees. It doesn't have to be perfect.
Okay.
Because you're gonna, you're actually going to iterate on when you make, so what you do is the basic procedure is that you're going to position your mount to point to those locations, and then
Yeah.
you're going to adjust either the azimuth or the altitude to minimize the amount of drift that you see on a star. So you're going to focus on a star. Let's start out at the meridian or near the meridian. Let's say within 10 degrees of the meridian, near the celestial equator or near dec equals 0. Okay, declination 0 near the meridian.
Right.
You'll focus on a star.
So it's going to look like your telescope's pointed about 12 o'clock high, okay, straight up, except that the telescope tube is aimed at 0 degrees dec, and you're finding a
Yeah,
star, right?
right. So 0, it's not 12 o'clock high. It's at the celestial equator, which is equal to 90 minus your latitude. Okay, so for here, it would be at 52 degrees altitude is where your scope would be pointed at, basically.
When I
Okay.
say 12 o'clock high, I'm referring to the meridian, this imaginary
Oh,
line
yeah,
that's
you're right. Yeah,
straight
right. So,
overhead. So if you're
right,
flying
right,
an airplane,
right.
you say 12 o'clock high, you mean it's straight up.
So
Right.
yeah, for those that don't quite understand what the meridian is, it's the line that goes from that goes directly overhead from the north to south. That's the line that you draw across the sky, and it passes through the zenith. And zenith is straight up. So the meridian passes. That's the line of the meridian. So what you'll do is you'll point your telescope there, and then the procedure basically has you observe the drift of the star, and we won't get any details right this minute about which way it drifts, but you'll look at the drift with the star near the meridian on the celestial equator or near the celestial equator, and you'll watch it move, and then you'll adjust your azimuth either left or right. Okay, and to bring the drift, to slow down the drift, to make it slower and slower to where it stays. And if you're doing this visually, you need a crosshair eyepiece to do this to get the best result.
Right. And if you don't have a crosshair eyepiece, what you can do is throw in a high power eyepiece and defocus a bright star so that the edges of the star are just almost touching the edge of the field of view. And then you can see if the star's drifting north or south pretty easy.
Right, right. So, I don't know what, I haven't really read this completely for a long time, so trying to re-understand what these drawings are showing here. What this is trying to show is if you move your mount left and right in azimuth, this is how the alignment goes between the North Celestial Pole, or the celestial equator and the telescope's celestial equator. They're misaligned, like I showed in that other drawing.
Yeah.
This is the misalignment.
So the line that has no stars is where your scope is physically pointing, right? And where
Right.
the stars are is actually where the line where the star should be if it's properly polar aligned.
Right, right. So that's kind of what that's showing there. This is what it should look like, of course. When you focus on a star and you're right on in azimuth, when you're dead on in azimuth, that star will not drift. Okay. Now that's for azimuth. Now, remember what happens on a gym mount when you move the scope from the meridian over to the eastern or the western horizon. Remember the telescope basically does this, right? Your field of view does this as it goes along because it's rotating in a circle. So your field of view, your drift goes from up and down at the meridian, right? Can you see I don't know if you can see my page. Let me stop my share for a second. I can make this clearer. So that's your field of view looking through the telescope, okay? At the meridian, let's say your landscape, or take a picture. That's what it looks like. And your star's in the center, and it won't, so you've adjusted it so now that it won't move up and down. That's the declination drift. Now, as you move it to the east or west, it's going to rotate around like that, right? As you move down to the horizon. So the reason to get near the horizon is that now the declination drift starts to show up again where it's moving sideways. Okay.
Mhm.
And that sideways motions can be corrected with the altitude adjustment. Okay.
Right.
Because, right. So that's the whole gist of the procedure, is to go to the, go near the meridian, adjust the azimuth to minimize the amount of drift up or down in your eyepiece with the, whether it's a close eye, you know, a defocused star and eyepiece, or whether it's a crosshair. You're going to just tweak the azimuth a little bit at a time until it stays right there. And every time you tweak the azimuth, you're going to have to move the scope to center the star again. That's a key thing too. You might even move it enough to where that star that you were focused on just goes completely out of the frame. All right. So you'll just have to pick another star that's in that field and center on it and say, okay, I'm going to watch this star drift now. And then you just keep tweaking it left or right until it stops drifting up and down. And then you're going to do the same thing when you move it around to the east or the west. You're going to do the same exact thing, except you're going to adjust the altitude knob instead of the azimuth knob.
So Pekka has a problem where he's got trees right on his meridian.
Yeah, that's a difficult thing. Does it go all the way? Does it go all the way to the zenith? Hopefully, it
Cut 'em
doesn't go
down.
all the way to the
Cut 'em down.
zenith.
Cut them down.
Nothing that a
Yeah.
chainsaw or a shotgun or
What? What
tree
tree?
removal system that
What
would.
tree are you shooting with a shotgun?
Yeah, that's one of the limitations of this procedure. You actually have to be able to see a star on
Yeah.
at that location. So even a star up real high above the celestial equator will work. It's just not as effective. You might have. So the issue is if you don't get a perfect star position, let's say you have to get a star near zenith to clear a tree or something, right, on
Yeah.
the meridian.
Peck
Then-
is saying if he can move 10 degrees off, then his problems are solved, and we think he can.
Oh yeah,
right?
you can move 10. In fact, you can iterate. Actually, you can iterate on either side of the tree. If you go 10 degrees to the left and 10 degrees to the right of the meridian, you could actually go back and
or
you
north
could
or
go
south.
back and forth. And of course, you'll do a pier flip, but
Yeah.
you
But
can go back
if
and forth.
What if it's north or south 10 degrees? Same thing?
Oh, of the celestial equator.
Yeah.
Oh yeah. In fact, north is better because it's higher up, right? Or south if you're in the southern hemisphere. South is better if you're in the southern hemisphere because it's higher up in the sky. If you got to get over something that's in the south or the north, then yes, that's fine. You use what you can, and then you learn the procedure and roll with it. You just have to deal with what you have. Nothing's ever perfect. So when you roll your mount over to the east or west, you can pick either side. You go back between the meridian and east, or back to meridian and east. You'll go back and forth and make the adjustment, because the other key thing about this adjustment is your mount should be level. Okay, so it's very important to level your tripod and your mount with the mount on there before you do this, because if it's not quite level, even if it's not too bad, when you think, oh, that's close enough, there's a little bit of interaction between the adjustments. Okay, and you may still have a little bit of interaction because of flexure and other things. You might have a little, so you'll have to iterate one or two times, going back and forth between east and west or to the meridian to do the adjustment. But once you nail it, once you dial it in, you can go back and forth and get on a star and it won't move at all. That's when you know you have near perfect polar alignment.
What about the software, Jerry? Is there any type of software in your experience? I know PhD2 does it.
That's a link. That's a link also that I've got here. Let me see.
I've never used it, and I don't know if SharpCap has the ability to do a drift alignment yet.
Okay, so here, let me share my. I'll share
And we
this
do,
link and
we
I'll-
have some other questions here too, so.
Okay, so let me get this real quick. I'll share my screen with this PhD drift alignment. I actually brought that one up too, and I'm gonna paste the where's the chat? So here's the web page for this, or people. If you can share that. So PhD2 does have drift alignment in it, and you can use that. And I'm going to scroll through this quickly just to browse it because I've never done this procedure with PhD2. But I actually talked to the original developer of PhD2. What's his name? Stark. Greg Stark.
Yeah, I think that's it.
Yeah, Craig.
And I noticed that on the guiding log that the drift, you could measure the drift rate and you could use it to adjust your mount and minimize the drift rate. And that's exactly what you can do. You basically center on a star and it'll tell you how much. And the neat thing about this is you don't have to wait 5 minutes to see the drift. It'll calculate it
It'll
immediately
calculate it immediately.
within a minute, easily. And now the closer you get, the longer you have to watch it to see what the actual drift rate is. But then once you get to a certain point, it's a simple matter of just tweaking it and getting it in. So this is an excellent way to use software and a camera
Mhm.
with your guide camera to do a drift alignment. And it works great. Now, I've also got, I talk about this in my book, and I talk about another method using a camera. I don't know if I got my, let's see here. I don't know if this might take a second. Let me stop my share.
That's fine. Harold Locke actually has a question. From what I have seen to have noticed, the RA and the deck function change roles while going through its tracking of an object. And solving a drift alignment when to solve the biggest errors of tracking. It sounds like a statement, but I know he asked as a question.
Say it again.
So verbatim, from what I've seemed to have noticed, that the RA and the deck functions change roles while going through its tracking of an object. And solving drift alignment will solve the biggest errors of tracking. So it sounds like he's saying.
Change roles.
Does he sound like plate solving?
Well, I'm not sure what he means by changes roles. It's definitely when you move the mount from the meridian over to the eastern or western horizon, the field rotates
Correct.
to where it looks like, and declination drift still goes north
still
and
goes
south, but it's
north-south.
sideways now instead of up and down, right?
Yeah.
That's what the difference. So I don't know if that's what he means by changes roles or what. But that's definitely a feature of what you'll see. So let me share this real quick and show you and talk to you about the way I do it. Now this takes longer than the PhD2 method does, but this is I'm just going to show you a photograph of a drift alignment. Can you see that?
Look, a beautiful time lapse.
Yeah. So what you do is basically over time. How do you indicate time on a picture like this? It's because you basically let it track. You start the image, you let it track for like 15 seconds, and it creates the starting point right there, like these bright stars right here at the beginning of the line.
Yeah.
And then you turn tracking off. Okay.
Yeah.
And when you turn tracking off, the star will drift this way.
Correct.
It depends on how you got your camera oriented.
Yeah,
of course.
true.
But it'll drift, okay? And you'll see it. So you let it drift for like 30 seconds, at least so you don't, go off the frame. And then as soon as it gets to 30 seconds or whatever, then you'll select 2 times sidereal rate on your speed, and you'll drive it back. And that little bit of gap right there shows you the declination drift over that time, over that 2-minute period. All right, so then you adjust your mount. You do it again.
I think Jerry's going to have another
Very
technical.
freeze framed
to
here.
get
Yeah.
these two lines to overlap. Oh, did I?
So go back to you. We initially said that there was a gap, and then you
Okay,
froze.
so it drifts off, and then you go 2 times sidereal rate, and it goes forward back to where you were at. And that gap is the declination drift that occurred during that 2-minute period. Okay. So the goal is so let's say you're at the meridian or on a star near the meridian. Now you're going to adjust the azimuth a tiny bit, and then you're going to do it again. And your goal is to get these 2 lines to overlap once you get it on. And that's how you can use your camera to do a drift align anywhere in the sky. You know, pretty much.
Harold clarified. I meant the movement of the OTA and the RA movement. I meant the movement of the OTA and the RA movement. Then the deck moves each side of the meridian. I think. I'm still not entirely sure.
Now, so remember that when you rotate the RA axis, you're leaving deck where it's at. You want to cross that same path in the sky
Mhm.
between east and west and through the meridian. So I'm not sure if that talks to what he's asking or speaking about, but the deck doesn't, you don't adjust, you don't change the deck typically.
So
You just-
on, yeah.
But you can. I mean, that's not to say you can't adjust the deck to point to another star in the east or the west. But typically, to minimize the amount of changes you have to do, you basically go between the meridian and east and west. And you can use, so the other thing that's kind of a subtle thing is that you don't have to use your mount to drive your scope. You could just release the clutch and release the RA clutch and just move the mount between the meridian and the east and west position.
So
You know, and then you can look through the eyepiece and then adjust and then go back and adjust and adjust and adjust. And it's faster than trying to move your mount back and forth because it takes like a couple minutes to get it back and forth, right? Between the horizon and the meridian.
Mhm.
So if you want to just loosen your clutch up and go back and forth and do the adjustment, altitude and azimuth adjustment, that's fine. Move it back to where your mount's actually pointed and do a plate solve and then recalibrate your mount to this position in the sky, and then you'll be done.
So Pekka has a question about if you could bring up the PhD2,
Okay.
The document again.
Yep.
He was curious on what the red line and the blue line represent on that.
Okay, so on that, I'll bring it up. The red line.
He's curious to know if you have to bring the blue line or basically put them together, if that's what.
No, one is declination, one is RA. That's what the difference is.
Okay.
So you're just looking at you want the RA to be flat like the declination is basically. So yes, that's true. You want to bring them together, but it's not. One doesn't have anything to do with the other. It's just that's what you want the RA to be, is flat instead of sloped. I'm trying to find this document again. Where the heck did you go? Oh, there it is. All right. Share.
Dun, 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 dun. Dun, 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 dun.
I'll get there. There we go.
There we go. So yeah, so see how the blue or teal line is just completely flat, which I'm assuming is, that's the RA.
So that's the RA. So the
And
deck is
and
what's
deck.
drifting. That's the declination drift.
Okay. So is that what you do? Is it'll basically just line up. So the RA is flat and you're bringing the deck up
Right, to be flat.
to be flat like the RA.
And they give
Okay.
you a measurement too.
Yes, they do. It's not, I mean, that's not bad deck drift in my opinion, because shoot, your total's 0.23 for the, it's a 196.
It's interesting that he gives you,
Yeah,
actually on the chart, he gives you the error, polar alignment error, calculated value. So
that is true, which is good.
Yeah, that's good. So you want to zero that out or get as close
Yeah.
to zero. But typically what you look for is you let it run for 5 minutes, however long your images are.
Hmm.
Let's say you're doing just 5 minutes at the most, 5 minutes of drift or 5 minute images. That means you can have a drift to where it's not really noticeable. It's maybe 1 arc second or 2 arc seconds of drift over 5 minutes. Would be good enough. Okay. Now he says this polar alignment error is 3 arc minutes basically. I'm not sure if that's
That doesn't seem
three
accurate.
arc minutes of drift
Or is it 3
over
arc?
time or what it is exactly. I haven't used this procedure to see how that works, to see what the numbers mean. But this would be I'd like to try this. This is an excellent addition.
Yeah.
Yeah, so that's what I would use. If you use PhD2 guiding with your auto guider anyway, you might as well use that to do polar alignment.
It's definitely a good tool to have, and especially, I mean, some people may not have eyepieces that do astrophotography.
Right.
And I mean, I have some, but I never use them. The only time I use them is if I bring out my big C11.
Well, and you may not buy a crosshair eyepiece unless you really get into it.
I have a normal eyepiece.
Yeah.
I didn't even realize you had to have a crosshair eyepiece.
Well,
at
to
all.
get the most precise alignment,
Yeah.
you want to do that.
So I think this honestly here, what I need to do, we need to get Annie, since she can't see the North Celestial Pole from her house. We need to actually make a video
Yeah.
of us doing it with Annie, so it can kind of tag along with what she's doing on her show. And it'll be good for me, so I need a refresher, and it'll be good for her because she's a beginner. And we can either use PhD or we can do it with a crosshair eyepiece.
One thing I will say is if you practice this and you do it 5 or 10 times, you might spend a half an hour to an hour messing with it the first time around, the first 2 times around. But once you get proficient at it, it's basically, it's like you got a habit and it's automatic. You don't really have to spend a lot of time doing a polar alignment.
That's true.
And you can buy tools like the Pole Master.
Yep.
I like the hybrid method where you use your existing tools like PhD2 guiding.
Yep.
To do the alignment where you'd have to spend extra money on a camera and some software and stuff. It's just all built in.
I agree. I definitely agree. Yeah, I think this will be another good episode. I mean, we'd have to do it. We'd have to make a video, then shorten it up, and then go from there. But yeah, that's great.
There's a couple. So this is what it looks like when it's lined up.
So it looks like you got a 0.11.
0.11 minutes.
Go back to where it's not lined up. Oh, it's pretty easy to see.
Yeah.
Yeah. So you make an adjustment.
Yeah, it's really easy.
It's
really easy.
This line just minimizing and minimizing, or getting worse if you're going the wrong direction.
Right, exactly. And this thing that's nice about this is it gives you a value to look for also down here.
Yeah.
There is one other thing. What the hell was it I was going to talk about?
Now, for people that are trying to do astrophotography, there's no reason to chase the perfect alignment.
No, actually, you don't want to chase it.
You don't want to chase it because you're going to be chasing it all night.
Well, and you don't want perfect alignment because most mounts, lower and middle, even mid-price mounts, are not perfect, and you want to be able to have your auto guider adjust.
Yeah, you want
your mount in one direction.
You want to load your gears.
You want to load your gear or bias it a certain direction. You still want to leave a little bit of declination drift in there.
I mean, if you have under 2 arc seconds, you are perfectly fine. You can get that 15-minute sub, no problem.
Oh, yeah.
It's just, there's no reason to chase that perfection at all.
Well, the reason for that is, let me stop my share.
I mean,
the reason for that is because of the lash in your gear. When you're perfectly aligned, your deck's going to be floating between those 2 positions. And it'll make your tracking worse. Where if you bias it, it's going to be pushing on one side all the time. And that minimizes the amount of motion on your deck axis. So that's the reason for that. And a lot of people, you know, when you buy Pole Master, that's almost like a scourge on the hobby, because people seem to think they need a perfect polar alignment.
Yeah.
If you got a perfect mount, then yes, you can deal
They
with
just don't know just how good it has to be, you know, so let's
Right.
make it perfect,
Right.
right?
right,
So,
exactly.
I mean, I take out the IXS 100 when I actually have clear skies. I literally just plop it, do a rough polar line, and I can get within, on the total RMS, it's 0.4, depending on what kind of system I'm using. So, I mean, I always try to go under 2 arc seconds. I don't try to chase for it because I'm just wasting imaging time at that point as well.
Right. The
So,
quickest way, if you can get under 1 arc, I would even say under 1 arc minute,
oh yeah.
or 1 arc second, I mean, of movement over whatever your exposure time is,
Mhm.
that's good enough.
And then the guiding system will take place with the pulsing and correcting the mount what it needs to be. So cool. Well, that kind of it gave me future ideas for future shows now. Thanks, Jerry.
Yeah, so I would suggest everyone go read those documents in the link and try to understand. I know a lot of it is pretty technical and got a little bit of math involved, but the more you understand about the mechanics of your mount and how it interacts with the sky and how it positions and these effects, then you'll understand how to adjust it better, and you'll say, oh, okay, I know exactly what's out, and I'll just tweak it a little bit and it'll be good enough. You know, you could get to the point where you plop it down, you've got marks on the ground where your tripod leg goes.
yeah,
You never adjust your altitude, you plop it down if it's portable, and you'll be within 5 arc and 10 arc minutes of the pole. And that might be good enough. It might only take you like 5 minutes to do a polar alignment or less. And you're not relying on anything but your skills and knowledge to do it, which is always gratifying.
Yep.
You know, you didn't spend $200 or $300 for a machine to do it for you.
every time, right?
Right.
So I think that about wraps it up. What do you think, Jerry? I mean, that gives me a basic understanding on how to do a drift alignment. So maybe I
Now
can
there
help.
are details on, you can determine which direction is drifting on which way to push your azimuth and your altitude, whether it needs to go up or down or left and right. Those are
Mhm.
details that you can read about in those documents that I sent you.
Mhm. Maybe
And
we.
I go over it. I have a procedure in my book also. Let me push my book here for a second. Let me see here.
Let me do a plug here real
Let me
quick.
plug my book and I'll
Let
show
me
you.
plug this.
I'll show you. Let me see here. All right, share my screen.
Shameless self-promotion. That's what it's called.
Self-promotion.
So this picture is in my book, and I've got procedures on how to do this written. You can see the detail of the procedure here, but I want to scroll up. Here's my book.
Which we have here at Explore Scientific, if you
Yep.
need.
Yep. So I've got a written procedure. Let me see, where's the procedure section? Okay, see this type of thing? I've got this procedure right here. Collimation, polar alignment procedure right there.
The CCD drift alignment method. There you go.
There it is. And I've got a link to that thing, but it's got a very detailed procedure on how to do stuff and which way to adjust it and how to obtain that image that I showed you earlier.
The elongated star with the tail kind of deal.
So the procedure is very detailed and it's somewhat technical, but if you want to learn how to do it yourself with skills and knowledge, then that's how you can do it.
Cool. Still think I need to do a video with Annie because it's fun to to get her involved. Because I mean, she's straight new. She can't see. I believe she can't see NZP because there's literally a gleaming light right in front of her apartment. So I think that'll be a good.
Oh yeah.
That will be a good test for her and see what she could do. and a test for me to see if I can teach her.
Yeah, that's the best way to learn anything is to try to teach it to somebody.
You
As
you
long
guys
as,
want to try answering an ASI Air question?
Of course.
Okay. So this is Lubo in China watching on YouTube. He says in ASI Air, when changing guiding scope binning to 2, my guiding is twice as good. Is it because my miscalculations of the pixel size or because it really is double better?
It
Good.
depends on what guide camera he's using.
Yeah.
So he's binning 2x2. So
Right.
he's shrinking the field of view or the ROI a lot more. I don't know why you would want to do that with guiding, Jerry. Maybe
well,
you have a better answer.
How
well,
about
the
if you have
thinking,
bad seeing, you know?
well, the seeing is a key thing to think about because what you're doing is when you're combining pixels, is you're averaging the signal.
Mhm.
So maybe it's not quite as noisy.
So your
Yeah,
SC and
scintillation,
yeah, that one.
scintillation.
Yeah,
So-
Norm
So
Hughes
that could be the
also-
reason. I'm not sure. I've never tried that to see what the difference would be, but that, in my mind, that could be part of it.
I'll bet part of the answer is that you're not chasing seeing conditions,
Right. That's
Versus-
exactly right
versus,
because it's averaging the scintillation. Right.
right?
Now, if that's another tip for auto guiding is you don't want to sample so fast, like down, you sample less than 1 second and do less than 1 second exposures, then you're starting to
Yeah.
get seeing to interact with the with your guiding, and it's not a good thing. So you want to do at least 1 second. Most people try to do 2 seconds or 3 seconds.
That's where I stick around.
Because the drift should not be so onerous or so great
Mhm.
that you have to keep up with it that fast, right?
And
That's
Lubo's
really what
got
the bottom line is.
he's got a 700 millimeter guide scope. So he's got a decent sized little refractor in there. So yeah, you're probably right, Jerry and Scott. That's probably just for oscillation and 2 seconds of sampling. So yeah, he's being in China, could be, if that's where he's from. I would assume that that's the reason why he's doing the bend too. So I just bend by 1. I don't bend. I've never messed with the bending on the guiding.
Now
Really?
the image, the point spread function is going to spread the starlight over several pixels, probably 10 to 20 pixels, and it's going to just calculate the centroid. So there's a calculation that it takes the weighting or the amount of light on each pixel and calculates where the star center is, and that's what it guides on, is that calculated centroid position. So again, if you can, when you bend, it seems to me like it would average out the light. So if you bend and then you defocus a little bit, that's the other thing to get a more accurate centroid or more precise centroid. You can defocus and it has more pixels to calculate a centroid from.
Yep.
Mhm.
That might help too. And the scintillation will be lower also.
Well, that you defocusing, that sparks another question. Becca asked, should you be really focused on a star or be a little defocused on a star? Scott, everybody likes your shirt. They have to see it apparently too.
They like my shirt.
They like your shirt. Well, Mike Wiesner does.
Okay, so my shirt, this was a gift that I got actually today from, one of our employees. It was very nice. Very nice. And did
So
I show my other little gift?
you showed us, but you didn't show everybody else.
I didn't show everybody. Okay.
I didn't see it. I don't think.
Yeah, you did,
I don't-
Jerry.
Did
This is
I?
ornament.
Oh, yeah. Mhm.
So
That was cool. That's cool.
on guiding, with your guide scope, Jerry, is it best to be in focus or to be a little out of focus?
I think it's a little out of focus because it allows the calculation for the centroid to be a little more precise and to detect changes more precisely. So yeah, so what that does, that effectively, that's almost like increasing the focal length in the effect that it has. So if you got a lower focal length guide scope, like say 200 millimeter versus a 400 millimeter or something, then if you defocus it, then you effectively magnify the image in terms of the light and the position that it's calculating. Now you'll have to have brighter stars to guide on in the field of view, but everything being equal, it's the same thing basically. Everything else being will be the same. in terms of the guiding performance. And that's something you could try, Tyler, when you get out, if you want to experiment.
Yeah,
You
I'm
could
gonna have to.
get as tightly focused as you can and see what the performance is, and then just run it out of focus just a tiny bit. And then you don't even have to turn off your tracking. You can just defocus the
Yeah.
guide scope and see what the performance looks like.
Yeah, and apparently Lubo in China was saying, does the ASI error, the question is if the ASI error miscalculates it, being in a bin of 2x2.
No,
I wouldn't
think
think
so.
so because it's
No,
using
it's-
PHD2 software.
well, it's just using the image itself. It doesn't care about the bending size. It just cares about how blobby the star is, and it calculates the centroid based on
Yeah.
that.
Okay. Hopefully that answers his question. Hopefully. And then Tarek has a problem. The problem I have with guiding is that I always disconnect from time to time when I connect to my power box. But if he stays connected straight to the PC, it stays connected all the time. So Tarek, that sounds like a possible power issue. Are you trying to use a powered USB hub, or are you using the Pegasus power box? Are you using the ASI Air? It all depends. There's a lot that goes into astrophotography, and it can be overwhelming at first, but I know you're experienced because you have a lot of stuff. So, not sure on that one, buddy. I think that about wraps up the show. Jerry, again, I appreciate your time. You got a nice little plug in there, so that's good.
Sure. Thank you.
Scott got to plug in his ornament and his wonderful his t-shirt. Everybody likes the floppy
Right,
disk.
I'm gonna show it again. Is the nice little ornament wherever. Well, who made this? This is
I don't know.
called the
Hallmark edition.
Old World Christmas Company. So, yeah, really cool stuff. Occasionally, I get a very nice Christmas ornament. So that's
I'm gonna be where Scott is right now.
yeah, get out of my office, man.
Lord. Let's see. Actually, another question, which Scott, you'll be able to answer this one. Lubo in China, do you plan to make a very short scope for wide imaging, around 250 mil?
Lubo, if I told you, I'd have to impair myself somehow. So what I'll tell you is that we have had designs for very short focal lengths, telescopes, but not every product that we design actually makes it to production. So we often make new designs of things, and it may be quite a bit of time before we actually come out with something. We have to wait for market conditions, the prices
we
of
have-
things, those kinds of things. So,
Customers have to ask for stuff, and we have to have a lot of customers ask for certain things before
That's
we
right.
consider, and decide, yes, we need to do this. So
Yeah.
if you can spread the word that you'd like us to do that, get all your Explore Scientific customer buddies to chime in and tell us, hey, I'd like
Sure.
to see this.
Sure. Yeah. And Norm Hughes points out you need something to rival the Red Cat. That was a very popular product, still is very popular. But Norm, the other side of that is you wonder, is the market saturated already? So by the virtue that you bring out your own, is it going to be as good as that competing product? Is it going to be less expensive than that competing product? Is it going to be twice as good as that competing product? So these are all issues that you have to work with, and when you're working with something that's already high performance out there, it takes a lot of figuring out. But short answer is, just to answer the question, Lubo, yes, we've designed something very short. And if we do come out with something like that, I think you're going to see it possibly in the next year or two, okay, if it makes it to production level.
Ooh. Juicy gossip for everybody. But that wraps it up with drift alignment here at Focus on Astrophotography. I hope everybody gathered something from this. I know I did. I hope everybody in the audience did as well. I'd like to thank Jerry and, of course, Scott for letting us do this episode. Hopefully next week will be just as impressive. I had to figure out who we're going to do, though.
Yes.
The holiday season is very rampant right now, and I have.
Right.
Oof.
It gets tougher because of holiday schedules. So
Billy Astro, we don't have Phil Flatners yet specific. We do, but we don't have any in stock right now. We're waiting for our Phil Flatners to get in, unfortunately, and that's where we're kind of sitting with that one. But other than that, that's all I got, folks.
well, and Beatrice Hines came back after a long absence. So it's nice to see Beatrice.
Oh, Beatrice.
Yeah, yeah. So, welcome back. And, all of you, we're getting so close now to the holiday, our holiday season. And we hope you all have a great one as you go into it. Spend as much time with your friends and family as you can. And up until that time, we will still continue to do some programming, including next Tuesday, we have the 76th Global Star Party. So until that time, I guess keep looking up, folks.
Thanks. Thanks,
Take
Tyler.
care. Good night.